Dear students, so welcome back to Industrial Property Law HOE 6065, and we are looking at patents. So, well, it seems that homework 1 for trademarks is going to be up soon. So, I hope you remember the deadlines and upload it on time in Moodle. Now, homework 2 for patents has also been put up now, and well, note the deadline, that will be 23rd May. Um, in just about 25 days or so. So be careful about the deadlines and make sure that you upload everything in time. And of course, if you have any difficulty in understanding the homework, don't hesitate to ask me. So, well, we are looking at patents last time and very general issues and topics and things about patenting and what can be patentable and what is, you know, the benefit of getting a patent for an invention. So today I'll look at a few more examples and then spend more time at the exact provisions of the European Patent Convention and how they deal with various issues. So, well, of course, what is applicable over here is, if you look at the European Patent Convention, then that would be part 2, the substantive patent law, and we're looking at articles 52 to 57. So from article 52 up to article 57 are the key issues related to patentability, and so these are very important to understand. I've been, of course, giving you a lot of examples, and I hope these examples also help to clarify certain things. Now, sometimes some of these examples I realize can be a bit strange, but yeah, I'm sure you'll get the hang of everything. So, what were we looking at in the previous lecture? And well, we were running short of time, so I had to sort of cut abruptly. But let's just try to understand a few issues here. Now, these relate to what is patentable, and of course, it has to be an invention. It has certain requirements. It should be capable of industrial applicability, that is utility. It should be novel, and then of course it should comprise of an inventive step. And then on top of that, we also have the requirement of patentable subject matters. So, well, this is quite a mouthful, but just to look at certain things. So, what are the problem areas that can arise? Now, this is, let's say, the drawing of a blood vessel. All right, this could be your artery or your vein or whatever. And well, if you eat too much red meat, not enough fiber and things like that, then of course you could have problems which deal with cholesterol. And what does cholesterol basically mean is that inside this pipe or this artery or vein blood vessel, you have this blockage, and this blockage is now going to result in all sorts of problems, right? So your heart has to pump faster, harder, and then you have high blood pressure, but there's not enough flow of blood through this particular vein or artery, and so these are the sort of issues that can cause all sorts of health problems. Now, of course, you could take a drug which sort of makes the size of the artery or vein bigger. So sort of it increases the diameter. So if that's the diameter, it increases it to a bigger size. So it sort of just opens up your artery in a way. And this could be a very good idea for dealing with your cholesterol, because you see the size difference over here. This is a certain size, and this is of course a much bigger size. So you're looking at almost 25-45% increase in size, or maybe even a bit more. And this would now enable the blood to flow more freely. So of course you already have such drugs that deal with such issues. Sometimes these drugs can work in different ways. If you have, for example, a headache, yeah, and then you could take ibuprofen or aspirin or something, and it sort of does the similar has a similar impact on your blood vessel, and it increases the diameter, and so blood can flow freely. Now, of course, when you look at this, you also then have to remember the example I gave last time, yeah, for Viagra, remember, and that's the similar concept that is working out over here. So what we are looking at is, as I explained last time, well, it's a blood flow problem, and you can cure the blood flow problem in different ways. So you see, many of these situations are quite similar. And why am I stressing upon this? It's because very often you can have a same or similar family of drugs dealing with different medical problems, for example. So, of course, this brings us to a very crucial aspect, which would be regarding novelty. And can you have an old drug can you use it for a new treatment or a new disease or a new health problem? So very often this is now old wine new bottle, yeah, or a new wine old bottle. And then of course these are just some examples of how problems can arise, because your invention has to be new, but it may not be entirely new. Rather, it may be for a new treatment. So what are we looking at over here in detail? Of course, invention is a new solution to a technical problem. Yeah, the problem may be old or new, but the solution has to be a new one. And if that is the case, then it would be an invention. So of course, in this scheme of things, if you just merely discover something that already exists in nature, that really won't help. You need to have human intervention. And so this would now be an issue that often comes up a lot across the whole spectrum of global patent laws, and that would be what has to be an invention. All right. And um, does an invention require a technical problem? So there's a lot of these key buzzwords which are of great relevance for us. So when you look at the European Patent Convention, Article 52, it outlines what are patentable inventions, and so European patents shall be granted for any invention, yeah, inventions in all fields of technology, all fields, provided that they are new, involve an inventive step, and are susceptible of industrial application. And of course, this does not include discoveries, scientific theories, mathematical methods, aesthetic creations. Aesthetics would go, under copyright, for example, or designs, presentations of information. Again, that's not allowed. Schemes, rules, and methods for performing mental acts, playing games, or doing business, and programs for computers. Now, you see, this is where all these problems start arising, and then of course. Also, there are certain issues that patentability of subject matter or activity referred to therein can be excluded also, in certain contexts. So this is not so straightforward anymore. And well, let's look at certain other areas. Yeah, one by one we look at all of these things, and so we try to sort of understand where we are and what's going on. So first of all, the key element here was it has to be an invention. Yes, that's the key area, and it has to be in a field of technology. And that's why I make a clear distinction between copyright, between designs, between trademarks and patents. Now, of course, along with this, there are also issues like exceptions to patentability. And so let's look at what is an invention. This would be the key criteria here. So all patents are inventions, but all inventions are not patents, or rather are not patentable. And so this is a very key element to keep in mind over here. Now, if you look in the case laws that are in Moodle, there's this one particular case which was Diamond versus Chakravarti. And when you read this case, it's basically about the scientist who invented a bacteria that eats oil. Now, yes, this is a matter from the United States, and of course, it's from the 1980s, so it's quite old school. It's one of the first biotechnology cases, but it has some very important and interesting elements over here. What basically happened was that the US Patent Office said, hey, how can a living organism be an invention? And how can it be patented? So this is the crux of the matter, as they would say. This is the key aspect here. Doesn't matter whether it's European Patent Convention or the US patent law or any other country's law. Um, if the law says it has to be an invention and it has to be new and never done before, all those sort of things, then can a newly invented bacteria be the subject matter of a patent? And then, of course, this matter went all the way to the US Supreme Court, and it's a very interesting judgment, so you should read it. The key aspect here was the court asked a simple question, which is, now, if it's an invention, it has to be new. If it's new, it means it's never existed before, so novelty is the criteria. And is it so that a bacteria exists in nature which can, a bacteria which can eat oil? If yes, then of course this is not new. But if such a bacteria does not exist and a scientist, a human being has invented it, so with a human intervention issue over here, then in that case it is patentable. Why not? So this is a very key aspect here, a very fundamental issue, if you may see it in that sense, because it says an invention has to be man-made, and if it's man-made, then it's not natural or God-made, or something that can be found otherwise. So this is a very, very crucial element here. Of course, if you look at Article 53, for example, it outlines exceptions to patentability, and it talks about order public or morality, and it talks about plants or animal varieties, about methods for treatment of human or animal body. And so these are all exceptions. So of course, would a bacteria that is invented be something which is immoral or against public morality or public order? So again, this is a very typical issue that comes up, a question that is asked, for example, with relation to inventions that deal with biotechnology. So what is immoral? And that's a very wide question. Of course, you will see that in IPR, this morality question comes up all the time, whether it's trademarks, whether it's designs, whether it's patents, and of course copyrights as well. But we are not looking at copyrights here because industrial property is not related with copyrights. Industrial property is dealing with trademarks, patents, and designs, and a few other things, but not copyright. So this is a very important issue that gets asked a lot. And this is because you have to remember that inventing something, especially biotechnology, can have pros and cons. All right. A very simple example of this is that the first of the Western European explorers who reached an island near Australia in the 16th century. So this is an interesting sort of a parable in a way. So the ship came to this island, and of course the ship had rats on it. So for the first time in the history of this island, rats were introduced into the ecosystem. So it's a small island, it's a closed system. You can't really escape from it. It has trees, it has plants, it has its old wildlife that's evolved over there over thousands of years. But they never had rats. So now you see the first ship comes, the sailing ship comes in the 16th century, sets anchor near the island, and of course with the sailors come and the explorers come the rats. Now, this was quite a problem because until that time, there were no natural predators for the birds on that island. So the birds would lay their eggs on the ground. And now you have a problem because the rats were eating the eggs that were on the ground. And this was not to the liking of the sailors because they also wanted to eat the same eggs. So the sailor said, hey, you know what? Cats kill rats, right? So why don't we introduce cats into the island system? So the next ship that came, they said, bring a cat along or a couple of cats. And they released the cats in the ecosystem. And the idea was that the cats would eat the rats. Yes, well, that's not how it always works because the cats saw the birds and the cats said, hey, why should we eat rats or chase the mice, and they're difficult to find, but these stupid birds are just looking at us, so why don't we just catch the birds and eat the birds instead? So now you had a problem because the cats were eating the birds. And this was even more upsetting for the sailors because what the hell, they wanted eggs, and now the mice are eating, the rats are eating the eggs, and the cats are eating the birds. So then somebody said, let's get a dog or dogs. Dogs will kill the cats. Problem solved. So now again, the third ship that came, they ordered dogs, and so you have an issue here. You're introducing new organisms into a closed ecosystem, and of course, things don't always work as planned. Now the problem was when they introduced the dogs chased the cats, but the cats could climb the trees. And then the dogs realized that on the island shores, on the beaches, there were seals. Yeah, seals. And so the dogs started attacking the seals and eating the seal babies. So now this became even more problematic for the sailors because they wanted to eat the seal meat as well. So now sailors can't eat eggs, they can't eat bird meat, now they also cannot eat seal meat. And so then somebody said, let's introduce bears into the ecosystem because bears like to attack and kill dogs. So you see how this goes. This is the problem with biotechnology. And this is of course an extreme example, but even with the coronavirus, the virus, you've seen how it mutates. There are all sorts of controversy theories, but we're not going into those. But the problem here is if you have a closed ecosystem and you introduce something new, then there can be unknown consequences. And that's why you have public morality, public order, and these issues. So exceptions to patentability, Article 53 deals with a lot of these real life problems that arise. Plant or animal varieties or essentially biological processes for the production of plants or animals are not patentable, but this provision shall not apply to microbiological processes or the products thereof. So again, you see there's a lot of scope for microbiology to play a role over here. Then methods for treatment of the human or animal body by surgery or therapy and diagnostic methods practiced on the human or animal body. These are not patentable. And of course, this would apply in the context, for example, of surgeons who do surgery. And if you know about surgery, then there is this issue that deals with how a surgeon can have access to different types of surgical methods. And this could also be an issue because surgeons need to have access to inventions which can cure all sorts of diseases. Now, of course, when you read this case law, it's about diagnostics and diagnostic methods. That's also there in Moodle. It's very interesting because it outlines what are the requirements for diagnostic processes. And of course, when you look at these issues, then the question that arises is, would it fit into the criteria of a diagnostic method? Very often it may not fit in that criteria. And so this case law outlines what are the 4 or 5 steps that are required to fulfill a diagnostic method. So if it fits into that system, in that method, then in that box of definition, then of course it would be a diagnostic method, but otherwise it would not qualify for that definition. If it's not fitting in the definition of a diagnostic method, then of course, it is patentable. So an example of that would be, let's say, what is required for diagnosis. Yeah, now you have certain criteria here. Let's look at a blood test. So you want to test whether you have diabetes. So what are the criteria for this? Well, first of all, you need to take the blood sample. Yeah. Of course, this has to be at a particular time of the day, or if it's a fasting blood sample, or generally if it's for any other purpose. Then once this is collected, it has to be now tested. So you have for this a certain table, and these are the normal figures, and anything besides this would be abnormal. So that would be the second criteria. Then the third criteria would now be, once you have this blood test and the report, it has to be interpreted by somebody who's an expert in this field. And then so you have certain criteria that are fulfilled over here. And if all of these 3, 4, or 5 points are fulfilled, then it's a diagnostic kit. But if it doesn't fulfill these criteria, then it's not a diagnostic kit. So another example would be, of course, you have to see the case law, diagnostic methods G104. But another method, another diagnostic kit would be for pregnancy analysis, right? So it's a quick test, or the coronavirus quick rapid test. And what you do is, for the pregnancy kit, you just put the sample, the drop of urine, and based on the pH level, it would tell you whether this is the reading and whether it is on this side or that side of the scale. And of course, it means that you are pregnant or you're not pregnant. But of course, this is not a complete diagnostic kit, because it's not a guarantee that you are pregnant. It just means that there is a probability that the pH level of your urine is different, and this could indicate various things besides, of course, pregnancy. So this is not a diagnostic kit, because this now has to be confirmed by a doctor who would use a different method, perhaps maybe a CAT scan or whatever. So what you are looking at is a device which is not now a diagnostic kit. If it's not a diagnostic kit, then it is patentable under Article 53. Article 53 subarticle C also lays down, of course, the aspect about this provision not applying to products or for use in any of these methods. So we come back to this old example I had. Here you have an injection, or here you have this this little device which is an inhaler, and it's used for giving out a small puff of the drug. And of course, these devices by themselves are patentable, but the method for treatment would not necessarily be patentable. So see these cases, and they are very interesting. I've also put up one more case. This is Dabus case. It's one of the more newer cases. It deals with patentability of something that is done in the context of artificial intelligence. So again, a very interesting viewpoint. And then of course, if you look in the Moodle notes, you have the European Patent Convention. You don't have to read everything, just the key aspects, articles 52 to 57, and a few more that might come up maybe with the procedure. Then there are the European Patent Office guidelines. It's almost 900 pages, but you just need to see part G, which deals with patentability. And this outlines various aspects. Then there's also the WIPO patent drafting manual. But again, this is a 3-credit course, so I will outline what you have to study and what you don't have to focus too much on. So don't worry about it. I mean, it looks a lot, but it's not obviously all going to be there for the studying part. So Article 54 deals with novelty, and it should be new if it is not forming part of the state of the art. And state of the art basically is defined as something which is publicly known, or people are aware of. And so you have to read article 54 carefully. But let me give you an example of what can be a problem with regard to novelty. So let's say this is a frog, and of course, somebody goes to the rainforest in Brazil and sees that the native tribes people have this traditional knowledge for thousands of years, and basically it's called, I don't know, Hakuna Matata juice. And it's simple, you just put 100 frogs inside a pot, boil it with milk and water or whatever, and you drink the juice or the soup, and it cures you. So of course, that's Hakuna Matata juice, comes from a very special frog to be found in Brazil. So let's say a scientist goes there from Estonia, Finland, Germany, somewhere, and looks at this and says, oh, well, obviously, it's not the frog. It's something inside the frog that is the key element here. Could be anywhere. Could be in the kidneys. Could be in the liver. Could be whatever. That ingredient which forms the soup. And just boiling it is only releasing that active compound. So let's say the scientist now takes a couple of these frogs back to the laboratory, does some research, and finally finds out that this is the compound, this is the structure. And now the scientist says, aha, I have found out the key ingredient. Basically, it's something in the eye of the frog, and when it's boiled, then it releases the compound. And so we don't need to find hundreds of these frogs, but instead you just can make the chemical compound, you can synthesize it, make it artificially, just like you make a lot of artificial things. It could be artificial insulin, it could be synthetic whatever, so there are all these possibilities. So basically what you're looking at here is a biologist, a microbiologist, and a chemist working together to form this sort of a compound. So another question comes up is, would such a thing be patentable? Is it new? Yeah, you see, so these are all the sort of questions that are very deep and which have to be really understood in detail. Another area would be, if you look at stem cells and stem cell research. So you have X, that is daddy, and Y is mummy, and so this is daddy's sperm, XY, and this is mummy's egg, XX. Daddy sperm, mummy's egg gets together, and now you have a zygote, whatever. It forms within the uterus, and then stem cells take over, and they create all sorts of endoplasm, whatever. And in the as the embryo develops, you have different cells creating different things. And so finally it sort of reaches a stage where from here you have now clear definition of the eyes, the nose, the ears. We are all initially female, but for some unknown reason, some of the embryos develop male sexual organs as they grow, and so this is how we are. And then these are your fingers, your toes, whatever, and this is the the tube that is connecting you to your mummy's womb. And so that's how you get your nutrition, and this is within the embryo. And then once the child is born, yes, and this umbilical cord is cut, now the child has no connection with the mother anymore, physically speaking. And of course this is now the situation where we are, and of course the stem cells will now stop reproducing, and you just grow bigger from this point onwards. The only new things that come may be your kneecaps. Yeah, that's something you're not born with, but you grow them later. All right, so once you are out of the womb, you don't grow a third eye or a fourth ear or something. No, you just become bigger. So these are stem cells, and of course this is a very natural way of your body coping with various pressures. Remember, uncontrolled growth of cells is what is called cancer. So of course you don't want uncontrolled growth of these sort of things when you are born, and so this sort of switches itself off. But you say this is not true for all animals. Stem cells can of course do a lot of amazing things. And some examples are lizards. If you cut a tail of a lizard, it can grow a new tail. Or a shark, if the teeth come out, they grow new teeth. So of course they have stem cells somehow that still operate and work. And this would be amazing in the case of a human being. Let's say you need a liver transplant or a kidney, or you want to regrow a missing arm or something, and then it would be so nice if you could activate the stem cells. So the question here is, would such a thing be patentable? And of course, we're looking at novelty here, and so this is of course a very key aspect that is of relevance. Article 55, non-prejudicial disclosures. So again, something to be taken into account. We're talking about novelty, but of course, what about some situations where you have a 6-month grace period? So that's covered here. Inventive step is also a key criteria. So what is an inventive step? Well, this is of course a very important element, and this is something that's not always easy to explain. So let's look at a teacup and a teapot. All right, so this is what these are. And well, so this is your teapot, and you use it to pour tea into your teacup. All right, and so this is a very simple issue. Yeah, you have tea and you pour it into the cup. Now how can you make the teapot better? Well, of course you could try to have different materials. You could have a self-heating thing. Maybe you could have some electric heating aspect. Maybe you could have a thermostat inside so that it stops at the right moment and doesn't keep on boiling forever. All sorts of things. But what's an inventive step? An invention shall be considered as involving an inventive step, Article 56, if, having regard to the state of the art, it is not obvious to a person skilled in the art. Yeah. And of course, this would cover all sorts of aspects, knowledge, scientific knowledge, whether it's in Wikipedia, whether it's been published, whether it's traditional knowledge. This can become a bit tricky sometimes. But how can you make this better? And there's a real life example of this. Somebody put 2 snouts. Yeah, you see, that's very important, because what you have done now is you have doubled output. You see, it was 100%, now it's 200%. After this, it doesn't matter if you put more snouts and stuff, but this is inventive step. You think out of the box. All right, that's very important element over here for industrial, for getting a patented invention. And the third is of course industrial application, Article 57. It is something which has to be capable of being made or used in any kind of industry. It can't be something which is fantastic. It has to be something rooted in real life. And an example of this would be outlined over here. It's stated, for example, with your with the invention of the rocket. Yeah. So basically, this is a very simple example. You want to fly into space, but how can you fly into space? There is gravity, and it sort of prevents you from going out of space. So there was a scientist, and he was this Russian guy, very famous person, and let's see, Konstantin, Soviet space program. Yeah, so his name was Konstantin Tsiolkovsky. Sorry, I'm not very good with Russian names. And basically what he did was, if you read more about him, Konstantin Eduardovich Tsiolkovsky, born in 1857, died in 1935. And basically this guy was doing amazing stuff. He was sort of coming up with ideas about how to overcome the gravitational pull. And if you see, for example, the Wikipedia page of his, He came out with these examples in 1896, came out with a theory, and then of course he even spoke about metallic balloons which have gases inside, and if you ignite them, when you mix them together, then Newton's third law, for every action there's an equal and opposite reaction. And if the exhaust pipe is at the bottom and there are these fins for controlling how it flies, then basically as the exhaust gases come out, you have upward motion. And so this is of course very nice, but you see, he was writing all of this and published all of this in 1905. Yeah, I mean, that's crazy, right? Because this is not really applicable as such. This is just something that is futuristic mumbo jumbo, so that will not help. So what we need are, of course, inventions which require certain things. They have to be industrially applicable, so rooted in reality, capable of practical use. They have to be novel. They have to, so that means confidentiality, not being published before or anything, as is mentioned in the notes. They have to be non-obvious, and of course, they have to be patentable subject matter. But the key criteria here is they have to be all of this. Yeah, it's not novelty or inventiveness or industrial applicability. No, it has to be novelty and inventiveness and industrial applicability, and of course it has to be patentable, and it of course has to be an invention. It has to be for a technical solution. So all of these are very important. So you have all of these criteria mixed together, and if you fulfill this criteria, then of course your invention is patentable. But then, as you can see in the case study, case law on the Dabus case, again, the question that comes up here is, what if you have all these criteria, but the invention is not by a human being? It's by a machine. So a code writes a code. How do you then get such a thing patented? And of course, the Dabus case outlines the criteria and the human element, human intervention, that is important. And if that is missing, then of course you cannot have a patent granted. So this is a lot of the stuff that goes on. I also teach biotechnology and IP, and of course in that we have cloning, and we look at various issues that come up over there. When you look at surgery or therapy and diagnostic methods as outlined in Article 53, there are again different cases that deal with this. What is surgery? Is it something that can only be done by a surgeon or a doctor? Yeah. And is it a surgical process if I make a cut in you but no blood comes out? So you see, is how do you define surgery? Because we are now looking at all of these issues from a purely legal viewpoint, and so everything now has to fit in a definition. If it fits in the definition, it's not patentable, or it is patentable. But if it doesn't fit in that definition, then we have a problem here when we interpret it from a legal viewpoint. So I hope some of these case laws will help you to understand what these issues are. Let's stop here for today. You have quite a bit. Besides the case laws, you have to also read 4 judgments. And next time we look at some of the more technical aspects of a patent application, and what is patentable and what is not allowed to write in a patent invention application and stuff like that. So let's stop here for now, and we'll see each other again, or rather you'll see me next week. So until then, have a nice time. Goodbye.